Hello everyone. Welcome to lecture 19 of module 9 on Scilab, an open source software designed for numerical computation and scientific problem solving. I am Dr. Kishore Kashyap and I will be guiding you through Scilab conditional statements. As your instructor for this lecture, my goal is to make these concepts easy to understand and practical for solving real-world problems. Let's make this a productive and enjoyable session together. I am excited to have you here today as we continue our exploration of this powerful tool. In the previous lectures, you gained a solid foundation in Scilab. You learned how to install it on popular operating systems and were introduced to its versatile environment. We also compared Scilab with other numerical computation tools, which help us understand its unique features and advantages. These discussions laid the groundwork for deeper understanding and practical use of Scilab. Today, we will shift our focus to one of the most fundamental and practical aspects of programming, the conditional statements. These are indispensable tools in any programming language, including Scilab. They allow us to create programs that can make decisions, adapt to different situations, and execute specific instructions based on given conditions. This capability is essential for solving dynamic, real-world problems efficiently. In this lecture, we will discuss what conditional statements are. We will break down their concept and significance in programming. How conditional statements work in Scilab. You will learn the syntax and structure, including constructs like if, else, and else if. Practical applications. We will dive into examples that showcase how conditional statements can be used to build flexible solutions for real-world problems, all within Scilab's environment. By the end of this session, you'll have a clear understanding of how to use conditional statements effectively and confidently in Scilab. So let's dive right in and unlock these critical programming concepts together.
So what are conditional statements? Conditional statements allow us to make decisions in code, making programs more dynamic and interactive. Conditional statements are used in programming to control the flow of execution based on conditions. This allows programs to behave differently under different circumstances. For example, a thermostat turns on the heater if the temperature falls below a certain point. Similarly, in programming, we can instruct the computer to execute specific blocks of code based on conditions. Two examples here. If the temperature is below 14 degrees Celsius, turn on the heater. If a student's grade is 80 or above, assign an A. So, in a nutshell, conditional statements help us to execute certain part of the code depending upon the conditions we provide. Now, let us explore the purpose of conditional statements. Conditional statements serve several purposes in programming. For instance, make programs dynamic and responsive, reduce redundancy by avoiding unnecessary repetitions, allow for better decision making in code, essential for handling user inputs and automated processes. These are all important aspects of conditional statements. Let us look these points more closely. So number one, make programs dynamic and responsive. Conditional statements allow program to adapt to various inputs and scenarios. For example, an online form may enable or disable a submit button based on user input. A real world example may be like this one. Say we have a weather app displaying different icons, but we can control how the icons look like depending upon the current temperature or humidity levels through our if else statements. For example, say if the weather is raining, the icon may have some clouds and raindrops falling from the sky. And say if the weather or the sun is shining hot, then we may have a sun in the icon. Another purpose of conditional statement is to reduce redundancy. Reduce redundancy by avoiding unnecessary repetition. Instead of writing multiple sets of repetitive code, conditional statements allow efficient handling of different cases with minimal redundancy or repetition. For example, instead of creating separate discount functions for different customer categories, a single if-else block can apply the appropriate discount. So we can encode or we can encapsulate the categories of the customers and make if-else statements. For example, if the category of the customer is A, then discount amount will be some XYZ. If the category of the customer is B, then the discount amount will be something else, and this will go on. The next purpose is allow for better decision making in code. Programs use conditions to determine the next step in a process, improving decision making capabilities. Example, a recommendation engine in an e-commerce website suggests products based on user preferences. This is another purpose of conditional statements, essential for handling user inputs and automated processes. Programs often need to validate and process user inputs. Conditional statements help determine if inputs meet specific criteria before proceeding. Example, a login system checking if the entered username and password match stored credential before granting access. In automation, smart home devices use conditions to control appliances, such as turning off lights when no motion is detected. Now, we'll examine how actually the conditional statements look like in Silent. We will first explore the most basic form of decision making, which is if statement. The if statement is the most basic or simplest form of decision making. Here, in the left hand side, we can see the syntax of if condition. So we have the if keyword, then there is a condition, and then keyword, and at the end we will see an end keyword. In between these two uh, extremes, that means if condition and end condition, we will put our block of codes to be executed when the condition becomes true. In the right hand side of the screen, you can see one example where we have declared a variable x. There is the if statement, and the condition we put is if x is greater than 5, then display x is greater than 5. This is a message. Displays a function to print the whatever we put there into the screen. So here the value of x is 10. So the condition x is greater than 5 will be true, and the message will get printed like x is greater than 5. Now say we put the value of x as 4. Then the x greater than 5 condition will not be true and will not see any kind of display, because the code block which is put in between if and end will be displayed or will be executed only if the condition is true. Okay, now if x is not greater than 5, then what will happen? In this case, for this particular example, nothing will happen because we yet haven't provided anything to do. So let's go to the next slide to examine what will happen if the condition is false. Here comes the if-else statement. So if-else statement extend the if structure by adding an alternative path when the condition is false. This ensures that exactly one of the two blocks of code executes based on the condition's truth value. Syntax for the if condition is same, but instead of simple end, we'll have a else block. Else is another keyword. So if the condition is true, then the code inside the if block will be executed. If the condition is false, automatically the control will go to the else block, and the code inside the else block will be executed. So again, if you look into the example provided here, now in this example, we have assigned value 3 to x. Now you can see uh, in this case, x is not greater than 5 because the value of x is 3. So the program reads if x is greater than 5, then only display x is greater than 5. That means the first statement. Else, now as the value of x is not greater than 5, automatically the code inside the else block will be executed. So if we run this program, then the output will be x is not greater than 5. This is a very simple if else condition, but we can add more and more code depending upon the conditions, and we can have multiple conditions. We will look into these things in a later part of this lecture. But to understand how it is working, I have provided this very simple and basic example. Here only one thing we have to remember, that this is a kind of branching. Branching means either you go to left or right depending upon certain conditions. So if it's having a true condition, then execute the codes or the statement inside it. Else, do something. So this is what if else does. Now let us move to another example. In this example, we can see that there's a banking system where user can withdraw some amount depending upon the balance. So in this example, the user has balance amount of 1000 rupees and the user wants to withdraw 500 rupees. So in the condition, we have written that if the withdraw amount is less than equal to balance, then the transaction will be approved, or else some insufficient funds message will be displayed. So if you look at the console output, we can see the transaction is approved because the balance amount is 1000 and withdraw was 500. So the first condition, that means the if withdraw is less than equal to balance, is true and the transaction is approved. After exploring this basic conditional statement structure in Scilab, let us explore some slightly more complex structures in Scilab. Next is if else if else statement. The if else if else statement allows us to check multiple conditions in sequence. If the final condition is false, the next one is checked, and so on until a condition evaluates as true or the final else block is executed. So here is the syntax. You can see we have a if condition as earlier, then we have a else condition also at the end. But in between this initial if and the last else, we have another condition now, which is else if condition. So basically, we have two conditions to make. Either the first condition 1, if this is true, then the first block will be executed, and we can now put another condition, condition 2, in else if block. If both condition 1 and condition 2 is false, then automatically the code inside the else block will be executed. So here is an example where we can see there is a variable x and value 0 is assigned to x. Now we have made two check conditions. The first one is if x is greater than 0, then do something else. If x is less than 0, then do something else. If both conditions are false, then else. Else means to the third thing, that is the default fallback value. Now we can see the output in console. It is x is 0. Now why it is so? Because in the first condition inside if, we have seen that it is checking whether x is greater than 0, but the value of x is 0, so this condition is false. In the next part, else if, it is checked that whether x is less than 0, which is again false, so x is negative will not be evaluated. So both the conditions are false, automatically control goes to the else block. Now uh, we get this output as x is 0, and which is true in this case. So else if is as if you can think of having multiple um, if or else conditions. That means if I remove or if I separate else and if in from the middle one, okay, then what will happen? If x is greater than 0, then do something, else do something. Inside this else, we have another if else condition. So fundamentally, in the next couple of moments, we'll see there is another structure called nested if else. Before moving to nested if else statements, look at another example involving if else statement. In this system, we can see we have developed one text calculation system. Here, this script prompts the user to input their income and calculate tax based on different income brackets. So in the below console, we can see the annual income is input as 10 lakh rupees. So automatically tax is calculated as 3 lakhs depending upon the conditions here. Now move us to nested if else statements. So what is a nested if else statement? So a nested if else statement is an if else inside another if else. This is useful when multiple conditions need to be checked hierarchically. We can see one example use case here, checking eligibility for a scholarship based on both grades and attendance. So syntax is, you can see there is a hierarchical or embedding kind of thing here. That means we have if else blocks within another if else block. So if condition, the first if condition 1 is true, then automatically it will move to the second level of if else with condition 2. But if the first condition in the first if is false, automatically and the control will go to the last else part. So let us look at one of examples. So the example is scholarship eligibility. A student qualifies for a scholarship if they have marks greater than equal to 80, attendance greater than equal to 75. So we can see three examples, 1, 2, and 3, and we have different value for marks and attendance for three cases. And in the below console output, we can see uh, three level of output. The first output, congratulations, you are eligible for a scholarship, is for the first condition, our first set of values for marks and attendance. Second, you have good marks but attendance is low for a scholarship. That was the output for the second program, where you can see the mark is above 80, which is 85, but the attendance is below 75%. So the output is marks is good, but attendance is not up to the mark. And in the third case, we can see the both mark and attendance are below the threshold values. So the output is your marks are too low for our scholarship. Next, let us look how we can combine multiple conditions using logical operators. So what is the use of logical operators in conditional statements? Already we have learned about logical operators. So logical operators allow multiple conditions to be checked within a single if-else statement. There are three main logical operators in Scilab: AND, OR, and NOT. And in the previous classes in operators, we already have seen how this AND, OR, and NOT can be applied. So here's a quick look. Like we have a table here. We have operator in the first column. Then there are two variables, A and B. And if we apply a particular logical operator, what will be the outcome? Which is written in the description part. So AND operator, if applied to A and B, what will happen? It will return truth value true only for the case when both the logical expression A and B have truth value true. Likewise for OR, it will return the truth value true for when at least one of the logical expression A and B have truth value true. And this is not. It will return truth value true if the logical expression A has truth value false and vice versa. Now let's look at one particular example, checking loan approval. Here the conditions so that a person qualifies for a loan. So if the salary of the person is greater than equal to 50,000 per month and the customer have existing savings account, then only the loan will be approved. Here is the program where you can see salary is equal to 60,000 and the person have savings account. Here person T signifies true value, person F represents false. Hence, in the condition, if salary is greater than equal to 50,000 and has savings, that means if has savings is true, then loan approved, else loan denied. Now, both the conditions are true here because salary is 67, which is greater than 50,000, and has saving variable have value true. So salary greater than 50,000 true and has saving is also true. That's why the if condition is true and loan is approved. Now, say one of the condition is false. Say as saving is person F, that means having value false, then loan would be denied. So this is how we can combine more than one condition within a single if statement. What is the benefit of this? If say we don't use logical operators in conditional statements, then also we can actually have the program or write the program using if else condition or nested if else condition, but the resulting program will be longer and we may have some chances of placing some conditions which may be logically wrong because the program is longer now. So to make program shorter and to make it very concise and manageable, we can use logical operators like this. With this, we have explored ways to work with conditional statements in Scilab. We will now briefly discuss about some common mistakes, debugging tips, and some best practices while writing conditional statements. So what are the common mistakes and how to debug, or what are the debugging tips? So most common issues we have seen in conditional statements while writing. It's like, for example, forgetting n in the nested statement, using single equal sign instead of double equal sign for comparison, like whether a variable x is equal to 10 or not. Then instead of writing x equal 10, if I write x equal 10, then that will be an error. Then another one is overcomplicating logic with unnecessary conditions. Some debugging tips include use display statements to check intermediate values so that we can keep track whether we are going in the right direction or not. Next one is simplify conditions where possible. Let's look at some best practices So these are some of the best practices for writing conditional statements. Number one is use clear and simple logic. Do not make things overcomplicated. Second one is avoid deeply nested conditions. Third, test edge cases to ensure correctness. Now we will look into one by one. Use clear and simple logic. Always avoid overly complex conditions that are hard to understand. Break down complicated conditions into multiple simple statements. We'll look into the following example, all these statements. And this one is most important and um, more or less, sorry, more or less, normally what happens? Programmers or new students make this that we go for variable names like A, B, C, X, Y, Z. That's okay. That is not mandatory that we have to make it some meaningful name, but it is a good practice. Okay, so use meaningful variable names to make conditions self-explanatory. I suggest not only in conditional statements, but every aspect in the programming, like loop or conditions and other functions. So everywhere the variable name should be self-explanatory, because when we read our own code at a later stage, then we'll come to know, okay, this variable is for that particular purpose. So the first instance of the example, though both the programs are doing the same thing, but if you can see, the first if in, condition have very complex structure, but when you refactor, you see we have make it step by step procedure, and though they are doing the same thing, but now it is more readable and easily anyone can understand what the logic and how the conditions are tested. The next one is avoid deeply nested conditions, because when you nesting make nesting very excessive, it becomes very difficult to actually go through all the if else, and we'll forget what was the first if when you go deep into the innermost if. So if possible, deeply nested structures, we should actually break it down into a simpler one. The third one is test edge cases to ensure correctness. This is a very, very simple example, like checking for voting eligibility. We have written that if age is greater than or equal 18, then eligible to vote, else not eligible to vote. Now we may have three edge cases, which will be less than the threshold value, which is 18, or equal to and greater than the threshold value, to check whether it is working correctly. So edge cases is very crucial. We should test it very rigorously. Okay, till now we have seen if else and or conditional statements with its various facilities, like only if with else, then if else, and nested if else. Along with that, we have also looked into how logical operators can be used to facilitate different conditional statements. Now we will look into some real world examples, or how where these conditional statements can be used. Actually, uh, conditional statements are widely used everywhere. In every programming construct or programs, you will find at least one if or else condition. So it is nearly unavoidable. But we have listed a very few applications. The first one is financial decision making. A very, very basic example we have seen earlier in this session. Then in the earlier AI system and expert systems, earlier decades, if else condition or conditional statements were heavily used. Nowadays also, um, some amount of if else is used in AI based systems. The next one example we have given here is IoT applications for smart home automation. So, this is an example of a smart home lighting system. Here, we have given two conditions. If time is greater than equal to 18, that means in our 24 hours format, or light sensor is very dim, which is less than 50, then turn on lights, else turn off lights. This program segment, this block of code can be embedded into our larger IoT applications. We have even seen smart air conditioners where the logics of if else condition or conditional statements are put, like if the room temperature goes beyond certain limit, so automatically the temperature is adjusted, so and so in washing machines also, and various things. Okay, in our smart phones, like say we are the smartphone detects that we are in an ambient light environment, automatically the skin goes dimmer, so on. So conditional statements can be used everywhere and is used everywhere in any kind of programming language, not just Scilab. Um, I have given here a challenge for the learners. The task is simulate a traffic light system. Here we can use a sequence of if-else conditions to sense light states. So light states may be red or green or yellow depending upon certain conditions. So we will I would like to request the learners to experiment with this challenge, traffic light controlling system. One thing in programming we always have to remember is the more we practice, the more we learn. From our mistake, and our logical ability will start growing. At the end, there are some discussion questions. How do conditional statements improve software efficiency? Can you think of new applications? What challenges do you face when writing conditional statements? One by one, if we try to answer all these three questions, then I can assure you that you will have a very, very clear understanding of the purpose and use of conditional statements in Scilab.
Let's take a moment to recap what we have covered in this lecture on Scilab conditional statements. We began by introducing conditional statements, one of the most fundamental aspects of programming. These statements are essential for making decisions in your code, allowing you to control the flow of execution based on specific conditions. This capability makes program dynamic and flexible, enabling them to adapt to various scenarios. We then explored the core syntax of conditional statements in Scilab. This includes understanding the structure and usage of if, else, and else-if constructs. These are indispensable tools in many programming languages, including Scilab. We highlighted the importance of the then keyword, which indicates the block of code to execute when a condition is true, and the end keyword, which is required to close the conditional block properly. Next, we discussed the role of logical operators such as AND, OR, and NOT. These operations significantly enhance the functionality of conditional statements by allowing you to check multiple conditions simultaneously. This feature is especially useful when solving real-world problems that require evaluating complex criteria. We also dwelt into nested conditions, where you can place one if-else statement inside another. This technique is invaluable for handling more intricate decision-making scenarios. However, we emphasized the importance of keeping your code readable and straightforward, as deeply nested conditions can quickly become difficult to follow. To tie it all together, we explored a variety of practical examples, including programs to check If a number is positive or negative, assign grades based on marks, and calculate tax based on income. These examples demonstrated how you can apply conditional statements to solve real-world problems effectively within Scilab. Now that you have gained a solid foundation, the next step is to practice. I encourage you to experiment with different logical conditions and try building your own examples in Scilab. This hands-on approach will reinforce your understanding and help you become more confident in using conditional statements in your projects. Thank you for attending this lecture and actively participating. I hope you found it both informative and engaging. See you in the next lecture.